The recurrence allow us to calculate every possible score for Sij in a single grid. Similarly, the algorithm Manhattan tourist problem will apply this technique to solve the problem of the tourist in order to see the maximum number of attractions. So here the value of W having the arrow downwards is the two-dimensional array that will run in the north to south direction, and it will calculate the weights that is present in between. And similarly, the W that is had the arrow in the east direction is the two-dimensional array that run from west to east, and it will also calculate the weight edges that is present in between. So the W having the array downwards and has the I and j values is the weight of the edge between I and j minus 1 and between I and j original values. Similarly, the W having the arrow in the east direction is the weight of the edge between I minus 1. It is the opposite of the previous one. In the previous one we have taken j minus 1, and in this W we will take the I minus 1, and the value of j will remain the same, and the weight between the original values of I and j. So by calculating these two types of problems, we can find the edges weights in between these two values. So we can see this is the Manhattan tourist algorithm, and here we can see the value of W, and it is a two-dimensional array, and this is from north to south, and this is the path that determines from west to east, and we have the values n and m, that is we have calculated the weights that is present in the path. So the first step of the algorithm we will assign the value of 0 to the source value 0 and 0, and as we know the source value always have 0 as 0 from where the tourists will start moving to see the attractions. The second is we will assign the value 1 to n, and this value will assign to I means in the columns, and this for loop will apply for this. And to calculate we will assign the value of s j minus 1 0, and this W that will move in the south direction has the value of I0, and all this value will assign to the sj0. Similarly, as we have assigned the value of 1 to n to I, and in the fourth step we will assign the value 1 to m, and this value will be assigned to the j. And similarly, as we have seen in the step number 3, the step number 5 will have the same value of s0j1 plus W that will be in the east direction have the value 0j, and here we see the value of I and 0, and this value will be assigned to the s0j. And again the for loop we will assign the value 1 to n to I and 1 to m to j. And this is the very important step, the step number 8. This is the recursive step, and this will use the pre-calculated values and will proceed further. And by using this value, as we have seen previously, it will calculate the maximum value. For example, if we want to calculate the value of Sij, we have to use two different calculations, and the one which has the maximum value will be considered, and the other value will be discarded. And by using this we will get the value S, N and M. So we will see that in lines 1 to 5 set up the initial conditions of the matrix, and that is the matrix S. And the line 8, this one I already told you, respond to the recurrence that allows us to fill in the later table entries based on early's one. So we can use the early values and calculate the later ones, and there is no need to recalculate the values that have been calculated previously. So most of the dynamic programming algorithm we will develop in the context of DNA sequence comparison will be just like we have seen this algorithm Manhattan tourist problem. So we will generally just arrive at the recurrence like line number 8 and call it an algorithm with the understanding that the actual implementation will be similar to this algorithm.